Hello everyone. In this video, we'll discuss exercise 1.2 in real numbers chapter. So there are two type of problems in this exercise. One is just proving a number is irrational, and the second one is compound terms, which we'll be learning later in this video. So now the question goes like this: prove that root 5 is irrational. I think if you could recall in the previous videos, in the basics of real numbers, we have learned that root 5 is irrational because it would have a non-terminating, non-recurring decimal expansion. Now we are going to prove that. And this proof follows a similar approach, which means this can also be applied for root 3, root 2, and other irrational numbers as well. So we would have learned a couple of theorems and the procedures in the previous years. The proof of this particular concept is a bit different because it follows the method of contradiction, which means whatever is asked in the question, we assume the opposite. That is, we assume root 5 to be rational, and as you can see, that is the first step over here. And when we say root 5 is rational, then we would be able to write that root 5 in the form of p by q, because that is the definition of rationality, where p and q are integers and q not equal to 0. Now, again, root 5 can also be written as a by b, where a and b are coprimes. I would like to explain this particular step here. Um, for example, if the p by q that we have assumed is 5 by 15, I'm just giving some arbitrary numbers, then they may be further simplified to 1 by 3. So here, the p by q that we have assumed in the beginning, this fraction, need not be the most simplified form. It may further be divisible by a number. For example, in the example which I have mentioned, it is divisible in five times table. So further, after dividing them, the simplified fraction that we get is what we have assumed as a by b, and that's why we have also mentioned a and b are coprimes. Here, coprimes means their highest common factor is 1. This means that they cannot be further divided by any other number except 1. So the idea of coprimes is very important, where they do not get divisible by any other number apart from 1. So in some of the schools, some of the classes, they may directly go to this step called equals a by b. In some of the schools, they will teach p by q. Kindly follow whatever is taught in the school. But in the board examination, either of these will be accepted. And now what we do is we take squaring on both sides. Obviously, that is to eliminate the root. So when we square the left hand side, root 5 square becomes 5. The root and square get cancelled, we get 5. And the right side, when we square a square and b square, both get squared. And this b square in the right hand side has been taken to the left hand side. It becomes multiplication. So as you can see, 5b square equal to a square. And this will be our equation 1, which we'll be using later in the proof. And now when we come to this next step, we are taking that 5 to the denominator, as you can see here, because it's in multiplication. And once we are able to write it in this format, a square by 5, we are saying that 5 divides a square, and therefore 5 divides a as well. So this is again a theorem. For example, if 5 divides 25, then 5 will also divide the 25 is nothing but 5 square. So 5 will also divide 5. For example, if 5 divides 100, which is 10 square, then 5 will also divide 10. So this is something we know, and that is what we have written. 5 divides a square and 5 divides a as well. Now, we may have a question. How can we be sure, just because 5 is there in the denominator, how can we be sure that 5 will divide a square? That is because after dividing a square and 5, the value that we get is nothing but b square, and we have assumed b and q as integers. So in order to get this value as a whole number, if we have to get a complete number here, then 5 has to divide a square. If 5 doesn't divide a square, then b square will turn up as a decimal, which is what we have not assumed it as, we have assumed it as an integer. So after 5 divides a as well, when 5 divides a number, then we would be able to write it in the form of, yeah, when 5 divides a number, then we would be able to write it in the form of form like this. For example, when 5 divides 20, then I can write 20 equals 5 times 4. We know 5 divides 30, then we can write 30 equals 5 times 6. Likewise, here we have got 5 divides a, then we can write a equals 5 times some other number, and that variable is what we are assuming it as c over here. After this, we again square on both sides. We get a square equals 25c square. 5 square becomes 25. Now we bring in equation 1. In the place of a square, we can write b square. So now this becomes 5b square equals 25c square. Now this 25 is taken to the left hand side. You can see it's in the denominator. Now 5 gets cancelled 5 times. Now we get b square by 5. Now we can say similarly, like how we said in the first step, 5 divides b square and 5 divides b as well. Now in the first step, as you can see here, we have got 5 divides a. Here we have got 5 divides b. Now we can conclude by saying 5 divides a as well as b. But this contradicts our assumption that a and b are coprimes. I would like to bring our attention back to this step where we have assumed a and b as coprimes. When we say a and b are coprimes, we said they cannot be divided by any other number. But to the contrary, we can see here that 5 divides a as well as b, which means a and b are further divisible by 5. But we have assumed a and b are coprimes, which means they cannot be divisible by any other number. Therefore, our assumption is wrong that, we have assumed a and b are coprimes, which is wrong. Therefore, all our assumptions are wrong. And we can conclude by saying root 5 is irrational. An important thing to do in this problem is that we conclude it using the exact statement. That is very important. Now we go to the last type of concept in this particular chapter, which is compound terms. What we mean by compound terms is, instead of just giving proof that root 5 is irrational, they would give you some other numbers attached to it. And uh, these may be asked in 2 marks or 5 marks. If they ask this question in 5 mark, we have to take this root 5 separately, prove that root 5 is irrational, like how we did in the previous type. We have to prove, and then we have to continue with these steps. But if they ask it to 2 marks or 3 marks or 1 mark, then we just write the steps that follow. Method 1. There are 2 methods. I strongly recommend we follow method 1 because that is what is discussed in most of the schools and I widely accepted as well. Method 2 also is accepted in a few places. Kindly follow what is being told in your school. Now again, this question, we assume that what we are supposed to prove is irrational to be rational, as you can see. And then the same procedure, because it's rational, we are able to write it as a and b, where a and b are coprimes. The same procedure that we did in the previous concept. Now slowly we'll be isolating root 5. In the sense, it's called separating root 5. Now this 3 goes to the other side, it becomes it gets subtracted, as you can see, minus 3. And then before bringing this 2 to the denominator, a very important step is to take the LCM. So here by 1 and into b has been done. So the next step you can see a minus 3b by b. Now this 2 has to be taken to the denominator. Now we have successfully isolated root 5 alone. As you can see, the left hand side root 5 is irrational, which we already know. And in case of 5 mark question, we would have proved it above as well. Whereas the right hand side is rational. How do we know right hand side is rational? Because the ones that we have assumed as a and b and the numbers 3 and 2 are all integers. So the fraction which contains only integers will be rational. So this implies that the left hand side is irrational, but that cannot be equal to the right hand side, which is rational. Therefore, we can say our assumption is wrong, and therefore we prove 3 plus 2 root 5 is irrational. The other method using which some places, some schools will teach is method 2, which goes like this. The one that we are supposed to prove is 3 plus 2 root 5, isn't it? So now we slowly take this root 5 and we say it is irrational. Again, in case of 5 marks, we have to prove it. But here we just say it is irrational. We assume that we know that. And then we say we just take these two numbers, that is 2 root 5, and we say 2 is rational, root 5 is irrational. Therefore, they are in product. So we say product of a rational number and an irrational number is irrational, which we already know. Therefore, we say this part alone is irrational. Now that this part has been proved as irrational, then what we do is this irrational part and this is rational, and the sign that is in between is a sum. So sum of a rational number and an irrational number is irrational. So therefore we say the whole thing is irrational. With this, our concepts in real numbers is over. Kindly drop in your doubts or comments, which will help me address your queries on time. Thank you so much for listening.